All right, guys, let's take a look at practice handout 3, which is on Canvas. Question number 1. All right. So you're going to have to follow along because after we walk through all these questions, I'm going to then jump to the answer key. So this is going to take a minute. You can see balance the following equation and answer the following questions. Oh, there we go. All right. Which means we got to balance this equation first right here. All right. You always have to balance the equation. You guys are getting good at it. You know exactly what to do. I've then broken it down into two things. What mass of aluminum oxide is made from this mass of aluminum? So as we get to the answer key, when I write down 135 grams of aluminum, you should know what I'm talking about. Also, what mass of aluminum oxide is made from 160 grams of oxygen? So when we jump to 160 grams of oxygen, you should know what I'm talking about. Here, what's the limiting reagent? This is how I plan on asking these type of questions, this little layout here. What is a limiting reactant of 135 grams of aluminum if 135 grams of aluminum reacts with 160 grams of oxygen? So we're going to talk which one. It's just an identification thing. Which one is limiting reagent? What's the maximum amount of aluminum oxide I can make? What is the most that we can get out of this reaction? And then what's the percent yield, which is actual or theoretical times 100. We just did that in the last video. So now I'm going to jump over here to the answer key. All right, and buckle up. Here we go. So the first thing that you're going to do is this is the wrong answer key. So let's get the right one and life will be great. There we go. And screencast fire killing me. Right, there we are. Now we're back. We're back in business. Sorry about that. Okay. All right. As you can see up at the top, I kind of got a little problem with the printer, but it should be okay. You can see that there's a balanced equation there. 4 aluminums, 3 oxygens, 2 aluminum oxides. I'm crazy. If you remember back to the problem, I said, what amount of aluminum oxide can you make with 135 grams of aluminum? So we're starting here. There you go, 135 grams of aluminum. Molar mass of aluminum is 27. I did some rounding over 1 mole. Then there's 2 moles of Al2O3. You can see that from the balanced equation. Over 4 moles of Al. You can see that from the balanced equation. Then we have the molar mass of aluminum oxide, which is 102. I got that by doing 2 aluminums, 3 oxygens, divided by 1 mole. Well, divided by a mole. And we get 255 grams of aluminum oxide. As I jump down here to oxygen, see, this is from that question that we just did. I have 160 grams of oxygen. Here's the molar mass. Here's the mole ratio, which we get from the balanced equation. Here's the molar mass of aluminum oxide, and we end up with this mass. So here, there's a comparison now. So what is the limiting reagent? LR. Up here, you could see that when we use aluminum, we get a smaller value. That means aluminum is the limiting reagent. It limits the amount of aluminum oxide we can make. So that's our limiting reagent. The maximum amount of aluminum oxide we can make is dependent upon the limiting reagent. So you can see here, boom, that's the limiting reagent. This is the maximum amount of aluminum oxide we can make, so 255 grams. I said, okay, what is, I want to show you that. What is the percent yield? You could see here, it's the actual over theoretical times 100. We actually made 225. That is from the question. This 225 is from the question. Max amount, 255, that's our theoretical, how much we could make or should be able to make. Times 100 gives us 88.2%. I will always go to the 10th of a percent. After that, it gets a little bit, we don't need that type of precision. So that is percent yield. Please try question number 2 on this worksheet. We'll talk about it on Friday, but you need to be able to do this. All right, please try. It will not take you very long. Also, please finish assignment 7.2.